Hello everybody. Today we will start the next part, probability 2. So first let us do uh, conditional probability. First let us understand what is conditional probability. I hope you all of you have gone through the probability part 1 video. So there we all described about all the basics, foundations of probability. We discussed what is random experiment, what is sample space, what are outcomes, what is an event, what is exhaustive event, what is mutually exclusive events, right? We even discussed what is complementary events. Okay, so we have gone through some of the basic jargons of probability. I hope you have all gone through that video, so please watch that video before seeing this one. If you want to clear your basics. Okay, if that is clear, all the basics are okay, then yes, for sure you can directly watch this one. So let's start with conditional probability. Okay, so let's say you have a sample space S here, and you have two events, A and B, and this is the intersection part. Okay, A intersection B. So what is P of A given B has already occurred? So this is called as conditional probability. So let me write it. It is called probability of event A given event B has already occurred. Probability of event A given event B has already occurred. Okay, so this is called as P A given B has occurred. Now let's keep our common sense open here. Okay, let's use our common sense. So it's saying, we are saying probability of A given B. That means basically B is the sample space in this case, right? Because probability of A given B, it's saying, like, okay, we are saying B is there, what is the probability of A? That means now B is our sample space, and what is the probability that A part can occur? That means this much portion can occur. What is the probability? So we will write as probability of A intersection B, that is this much part divided by the sample space, which is B now, probability of B. If you remember, while I was discussing the classical definition of probability in the topic 1, I was not very inclined to say n divided by capital N, where n is the total sample space S. Okay, I was not inclined to see this because of this reason, actually. Because here the sample space can change, right? Like, okay, for this total thing, the sample space is S, but if you are doing conditional probability, then B becomes the sample space, right? Probability of A when B is done, we are saying B event has already occurred, and when we know that B event has already occurred, what will be the probability of A? Then we will say, okay, B has occurred. Then what will, then we know at least this thing, we know B has occurred, right? So this entire thing has been done. So this is our sample space now. And from there, what is the probability of A? Is this intersection part, P A intersection B divided by P B. Okay. I hope it is clear now. From there, what we can write, P of A intersection B equals P of A when B has occurred times P B, right? If we just cross multiply P B and we take it to the other side. I'm sorry. Okay, so if you need to know this thing, okay, let's discuss from basic sense. If A and B, if event A and B are independent events, okay, if A and B are independent events. So by independent events, what we mean by independent events, that it doesn't matter whether B has occurred or not. Probability of A does not depend on B and vice versa. And similarly, probability of B does not depend on A. They are independent to each other. Basically, what I mean by it, let's say probability of A when given B event has occurred. What is the probability of event A when event B has already occurred? We know it. What and A and B are independent to each other, independent events. Then probability of A given B will be probability of A. It does not even matter to A whether B has occurred or not. Okay. So similar, that's why the conditional probability will be same as the probability of A. Similarly, if probability of B given A, we are saying to B that for in this case A event has occurred, what will be the probability of B? Basically, A is a sample space now. Okay. So what will be the probability of A? It doesn't even matter to B whether A has occurred or not. Basically, that's what it's saying. So this will be probability of B. Okay. I hope this is clear to you. Let's go to the next part. Let's see this independent event a little bit further. Let's investigate this independent events from an example point of view. So I already said independent event is PA given another event B is equal to PA if A and B are independent to each other, right? A and B independent to each other. Similarly, P of B given A equals PB. Okay. Now let's say we are drawing a random experiment. Random experiment. So I already explained what is a random experiment and all those. I guess you guys all know it. So random, what is a random experiment? Drawing a card. So we are drawing a card from a deck of 52 cards. From our deck of 52 cards. Okay. So this is a random experiment. And one event among this random experiment, what is one event? Let's say event A. The card drawn is a spade. And what is event B? Let's say there is another event. The card drawn is an ace. For those of you who doesn't play cards or haven't played cards at all ever, let me just give a very brief on how cards look. So on the cards always have 52 cards in total, okay? And they are divided into four sets. Two, three, four. Okay. So there are like four sets. One is like spade, one is like diamond, okay? Diamond, one is clubs, and there is another one in hearts. Yeah, hearts. I just forgot. Okay, for a minute. Okay, spade, diamond, clubs, hearts. Okay, each will be divided into 13 cards. Each will have 13 cards, right? And these 13 cards will consist of one ace, okay, one king, one queen, and one jack. J. It's called. I don't know what. It's one J. Something like. It, oh, I don't know why I'm not able to write this queen. Okay, one J. I think it's called Jack. Okay, so one Jack, and the rest of the 10 cards or 9 cards will be from 2 all the way to 10. Okay, so this is a combination of 13 cards. Okay, yeah, it's 10, it's 9, 10, 11, 12, 13. Yes. So this is 13 cards. So similarly, this will be like this for all the sets. Only the colors will be different. Spade is of like, let's say a spade is a like one type of card is spade, one is diamond like this, different color. Clubs is like a different color like this. hearts is like this. Okay, spade is something like this in black, like the same like this in black. But you just need to know 13 cards which are divided into four parts. Okay, that's it. And if you want to know a little more in detail, go through Google. It's not a very difficult thing. Just for this problem, I gave you a little bit of hint on how cards look for those of you who haven't played cards even once in their life. Okay, which is a good thing also. I don't. That's fine. Okay. So random experiment. It's saying the card drawn is a spade A and the card drawn is an ace is B. Okay. So what will be probability of A? The card drawn is a spade. I said there will be 13 cards of spade. So this is a favorable event by the total number of events. Total number of events is 52. 52 cards are there. So it's like 1 by 4, right? So probability of B is the card drawn is an ace. I said every 13 cards like spade will have one ace, and then diamond will have one ace, clubs will have one ace, hearts will have one ace. So we have in total four ace. Four, and favorable event total number of events is 52. This means 1 by 13. Okay. Now you see actually event A and event B are independent to each other. The card drawn is a spade or a card draw because let's say you get given a deck of 52 cards and you are asked to draw one card from it. You drew it, it came out as a something, let's say some x. Okay, x3 of spade, let's say. Then you are told to put it back into the 52 deck. You put it back into 52 deck, and next time you are asked to draw it again. Now this next time that you are drawing is not related to the first time. It doesn't even matter what came in your first A, like is it a spade or an ace? It does not even matter. Each time you are pulling out a card from that deck, that is independent of the other time that you are pulling, right? All the events are independent to each other. Okay. So the card drawn is a spade is independent to the card drawn is an ace or not. Right? That's we want to prove to it. So now let's go from the definitions. What is the probability of A given B? We don't want to use too much of our brain right now. We will go, okay, let's go with the definition of PA when given B, PA intersection B divided by P of B. This is our definition of conditional probability. What is of A intersection B? How many cards are there which are spade and which is an S? Well, how many cards are there which is a spade and which is an ace? Spade, there is only 13 cards, and from there we have only one ace. So basically this is one favorable event divided by total number of cards is 52. This is P of A intersection B. What is P of B? We already found P of B as 1 by 13. Probability that this is an ace, 4 by 52 is 1 by 13. So we get 1 by 13. This gives us 1 by 4. This gives us back P of A. So we see here P of A given B equals P of A. So that means hence proved that this is a condition, that this is an independent event, that these two events are independent to each other. Okay. Similarly, you can actually prove P of B given A equals P of B. I request you guys to do this on your own. You will do the same thing, P of B intersection A divided by P of B, and try to find that and see it will come as P of B. This is a very simple thing to do. Okay. Okay, let's continue. Now this figure that I'm drawing, this is a very important figure. I would like you guys to remember it actually, because this will clear a lot of concepts which we will be discussing now, like theorem of total probability based theorem. So let's say this is your sample space S. Okay, and this is a event A that took place. Okay, and it is divided into, let's say this is event E1, event E1 is this much of the sample space, event E2 is this much of the sample space, event E3 is this much of the sample space, event E4 is this much of the sample space, like this. Let's say the last one is En is this much of the sample space. Okay, and there is an event which is happening here, which is event A, which you can see in the middle. Okay, so you see what will be this part. This part you can see it's A intersection E1, right? If this is entire is A, this part is E1, so this part is A intersection E1, right? Okay, so how can we write? And also, okay, you see, you can, this is very obvious from the diagram itself. E1, E2, they are not intersecting with each other. If they are not intersecting with each other, what we will say? They are mutually exclusive events, right? EI intersection EJ, this event is phi, null set basically. So these are mutually exclusive events. Now we will find, let's say, what is PA. We want to find PA in terms of E1. Okay, so we want to find what is PA. That is like what, that is the total probability. So PA, you see, we can write is at PA intersection E1, like this part, then this part, plus PA intersection E2, plus, let's say, this part, PA intersection E3, like this, all of it. Okay, like this we will add it up, plus PA intersection En. Right? Okay, so what is P of A intersection E1? So P of A intersection E1 equals P of A when we know E1, right, times P of E1. That's what is PA intersection E1. We already did it before, right? In the last sheet, couple of sheets back, we did discuss Cody's conditional probability, right? So we got P of A when A when given E1 equals P of A intersection E1 divided by P of E1, right? So, and I also discussed at that time when it's P of A given E1 equals P of A intersection E1 divided by P of E1. Basically, when E1 is given, then this becomes a sample space P of E1, and A intersection E1, basically we only the part where A is intersecting with E1, that should be in the numerator. Okay, so that gives us P of A intersection E1 equals P of A given E1 times P of E1, right? So this one. So similarly we go the same way. P of A intersection E2 is PA given E2, that is what is this part, P of A given E2 times P of E2. Okay, like this we will write the last term as P of A intersection En times P of En. So this entire addition is PA. So the entire probability of PA we are writing in terms of A given E1 and event E1, like that, A given E2 and E2, right? So this is called as, which we just derived actually from basic sense of total probability, we just derived, but this is formally known as theorem of total probability. Theorem of total probability. But please understand this thing, that is more important than just remembering this theorem, because you cannot just use it for sure if you just remember it. Yes, to getting having a sense of it, like what will be the structure, those is fine, but you have to understand it. What is total probability, like P of A given E1 times E1, and why we are doing it, because this is the intersection, then we are adding all the intersections, and then finally we are getting this total probability A. Okay, now let's do a quick example. Let's say in a corporation there are some male employees and there are some female employees. Okay, there, let's say there are some male employees, there are some female employees, and no, not in a corporation. Let's say in a locality. Let's say in a locality there are some male, there are some female, and some people in that locality are employed and some are unemployed. Okay, so let me write the numbers. How many are employed? How many are not employed? Let's say 200, 120, 60, 80. Now they have asked you to find what is the probability of M given E1, given E. That is how many, what is the probability that it is a male given they are employed. Okay, so employed is the employed is the sample space basically, right? And what is the probability of M? It's a male. So you see from common sense you can say they are employed means it has to form here. This should be the sample space. That is, they are at least employed. At least they are employed. So this should be the sample space. So denominator should be 320. And they are saying find how many among them are males. So male, how many? 200. So you see, you can directly write 200 by 320. But for exams like board exams and exams where we have to write it, not like optional questions are there, you can just come to the correct answers like JE or AIEEE, WBJ, like that. Now it's not AIEEE, so I think JE Advanced Mains or WBJ, something like that. Then this is fine. But let's say in a board exams you have to do, you cannot if you just write this, they will not give you any marks. So for that terms, we will go for a board exam point of view. Let's go with the definition of P of M when given E. What is it? We know it should be M intersection E divided by probability of E, right? What is probability of M intersection E? M, it should be intersection of M and E, right? That is, it should be a male and it should be employed. So how many males and employed are there? 200. So what is that probability? 200 divided by total number. What is the total number? 200 plus 120 plus 60 plus 80. So 200 plus 120 plus 60 plus 80, right? And probability probability that they are employed, so that probability is 200 plus 320 is in the numerator. Sorry, 200 plus 120 is in the numerator. This number of people are employed. And what is the total number? Total number of people in that locality is 200 plus 120 plus 60 plus 80, right? So this two gets cancelled out. We get it as 200 divided by 320. You see, we get the same answer. We arrived at the same answer. So this is just to illustrate conditional probability. I just wanted to illustrate this example one more time of conditional probability. So now, so you guys, I think you guys have understood conditional probability. You guys have understood theorem of total probability, right? So conditional probability, you guys got it, I guess. Theorem of total probability. Okay. Now it's a good time to understand what is Bayes theorem. Okay, what is Bayes theorem? Before we directly go into what is Bayes theorem, I want to take a little detour and just explain or rather discuss one basic probability concept with you here. Let's say this is a sample space S where this there are two bags, bag 1, bag 2. Okay, so bag 1 has 2 white balls and 3 red balls. Bag 2 has 4 white balls and 5 red balls. Okay, so probability of a white ball What is the probability of a white ball drawn from these bags? Okay. So what is the probability? Let's say probability of a white ball drawn from these bags. So how we will solve this problem? So this can be divided in two parts, right? What is the probability of a white ball drawn from this bag? So we have to find we have to say probability the ball can be drawn from bag 1 or from bag 2, right? So there are two probabilities. So probability they are either drawn from bag 1, or then we will write as plus, or probability they can be drawn from bag 2 also, right? So what is the probability when it's bag 1? So basically we are selecting this bag then, right? So there are two bags. If you select this bag, what is the probability that you will select this bag 1 out of this two bag? This is half, right? 50% chance you will select bag 1. And from there, half times you also have to select a white ball. So what is the probability that instead of we have two white balls here and three red balls here? So instead of that, from that collection of five balls you will select a white ball. What is the probability? Favorable events is 2, right? Total number is 5. So 2 by 5, right? Plus, what is the probability that you will select back 2? Similarly, it's half. What is the probability that it has to be a white ball? So 4, because you have 4 white balls and 5 red balls in back 2. So 4 divided by 9, right? So this answer will give you the probability of a white ball drawn from either of the bags, bag 1 or bag 2. Okay. Now, let's say we are given a different scenario this time. If we are given the ball drawn is white, now we will go now, this time we found out what is the probability of a white ball drawn from this bag. Now let's say they tell us if we are given the ball that is drawn. I want you to please pay attention, because this is a little tricky scenario. So ball that is drawn is white, they tell you this thing. Okay, can we find the probability that the ball is drawn from bag 1? Now they are saying you that the ball drawn is white. Can we find probability that the ball drawn is from bag 1? So we have to find this inversely, right? Now they are saying find the probability that this is drawn from bag 1 instead of what is the probability of a white ball. Then we are doing, okay, let's say the ball is drawn from this bag and the ball is drawn from this bag. Then we are adding it up and we are getting the probability it's a white ball. Why it's a white ball drawn from either of the bags. But if I say, okay, I am telling you this time that the ball that is drawn is white. Okay, so this information is given to you. Now can you find what's the ball that the ball that is drawn is from either one, either bag 1 or bag 2? So this is called as reverse probability. This is called as reverse probability. Okay, so this problem is solved by Bayes. So Bayes solved this problem. So that's when he gave a theorem, Bayes theorem. But this is also coming from basic sense actually. Okay, I will do the proof. When I will do the proof, you will understand that it's coming from total probability actually, theorem of total probability. So as I discussed, as I said before also, it's better if you remember. It's always very use. This diagram is very useful actually. So this is PFA. There are some events E1, E2. You will never get confused if you remember this diagram. E3 all the way till En. This is A event. Okay. Now, what is Bayes saying is when I draw, when I know that the event A has occurred. Similarly, you try to draw an analogy from the example that I gave previously. If I know that the ball drawn is white, I told you the ball drawn is white, then what is the probability that this is drawn from bag A? Now, in this case, I'm telling you the event A has occurred. What is the probability that this is due to event E1? That is, this A event is coming from this portion. Okay, I am telling you that A event has occurred, but the A can come from this portion also. Sorry. A can come from this portion, this portion, this portion, this portion. What is the probability that this A event is coming from E1 portion? That is the crux of Bayes theorem. So basically, I am trying to say what is the probability of E1 given A. Now I'm saying A has occurred. What is the probability of E1? That is this much portion. What is the probability? Okay. So this what you will do. So this will be this portion, which is, if you see this portion I discussed before, this is probability of A given E1 times probability of E1, right? This is actually probability of A intersection E1. So we have to write this portion divided by the entire probability. That will be the probability that it is coming from this part. The probability of E1 given A has occurred. Okay. So this will be probability of A given E1 times probability of E1 by total probability. So this is probability of A given E1 times probability of E1 divided by probability of A given E1 times probability of E1 plus probability of A given E2 times probability of E2 plus all the way till probability of A given En times probability of En. So that is the probability that that A has occurred from E1. Given A, that I am saying, if it's a white ball, what's the probability that is drawn from bag 1? If it is a white ball, let's consider this as white ball. What's the probability is drawn from bag 1? So that is what we are saying from here. So what is the probability is drawing from bag 1 if it's a white ball? So we have to do basically this much portion. This is the probability divided by the total probability that the ball is coming from this portion, right? The ball is not coming from any other portion. So how we will do that? We will do it this part. So we already discussed that this part is equals P of A intersection E1. P A intersection E1 means P of A given E1 times P of E1, right? The reason we wrote it like this, because these are like, this is not this, although this is the inverse probability, but these are all straight probabilities. Like, what is the probability of A given E1 has E1? That means what is the probability of a white ball drawn from bag 1? We know it. If it's bag 1, let's say the previous example, what is the probability, or it's of drawing a white ball from bag 1? We know it's 2 by 5. Similarly, if I tell you if it is drawn from bag 1, you know what's the probability of it's a white ball. And also you know what is the probability of a bag 1, right? Probability of bag 1, if there are two bags, what is the probability that I will choose bag 1? Half, right? You already did it, right? You can choose bag 1 in half. And if I tell you if it's a bag 1, what is the probability of white ball? You already wrote 2 by 5. So these probabilities we already know. All these probabilities we know. So from this probability we can find that event, that probability that A has come from this E1 space. Okay. So this is Bayes theorem basically. Let me just write it a little bit clearly. P of E1 when A is given, it is P of A when E1 is known times P of E1 divided by P of A when E1 is given, P of E1 plus P of A when E2 is given times P of E2 all the way till P of A when En is given times P of En. So this is Bayes theorem. Okay, this is Bayes theorem. And also please remember this event E1, E2, E3, which are like happened before the main event A, right? So these are called the probability of E1, P1, P2, P3. These are called as a priori probability. Okay. So now let's consider an example. We will take a easy example just to illustrate the point so that you guys can cement the concept and concretize it. Okay, what's happening? We will go by the same example that we discussed before. This is bag 1, this is bag 2, similar like that. Let's say you have 3 red balls and 4 white balls, and you have 5 red balls and 6 black balls. 6, sorry, white balls. Okay, so 5 red, 6 white, 3 red, and 4 white. So one ball is drawn at random from one of the bags and it is found to be red. What is the probability that is from bag 2? One ball drawn at random found to be a red ball. So what is the probability that it is drawn from bag 2? Okay, what is the probability that is drawn from bag 2? See, this is just for understanding, right? I'm just drawing this the same figure as before. Let's say this is the event of drawing a red ball. This is the event of drawing a red ball. Now this time there are only two bags. Basically there are a priori probabilities. There are like two events like that. One is bag 1, one is bag 2, right? So what is the probability that it is drawn from bag 2? So I need to find this part. What is the probability that it comes from this part? So and it said what is the probability? It said it's a red ball. What is the probability that it came from bag 2? So what we will do, first we will find this probability. So you see we don't know what is b2 when given r, but we know what is r when given b2, right? So we will use Bayes theorem. We will write okay, this part can be written as r intersection b2, r intersection b2 can be written as r given b2 times b2, right? We know both the terms. What is the probability of r given b2 times probability of b2? We know both the terms, divided by total probability. Probability given r that when given b2 times pb2, this part and this part, both the parts we have to write, right? P of b2 plus probability of r given b1 times p of b1, right? So what is the probability of r given b2? They are saying you have drawn it from back 2. What is the probability of r? You see there are like 5 red balls and total balls in this bags is 11. So it is 5 by 11, right? It is 5 by 11 times. What is the probability? It's bag 2. So there are only two bags, bag 1, bag 2. So bag 2 probability, you see, I drew it from middle also, right? It's bag 1 probability is half, bag 2 probability is half, right? Divided by probability of r given bag 2. Similarly, it's like 5 divided by 11 times probability it's a bag 2, that is a half, plus probability of r given bag 1. So what is the probability that it is a red ball given bag 1? So I'm saying, okay, now you have to draw, it's from this bag, basically given bag 1. So three red balls are there out of 7 balls in this bag, right? So we have to write 3 divided by 7, right? And what is the probability of it's a bag 1 out of 2 bags? What's the probability? It's half. Okay, so if we calculate it, you will see we'll get it as 35 by 68. That is not important. Understanding the concepts is very important. Also, let's say this is, we can do it. So this is the answer basically, right? I'm just doing one quick thing here. You can you can write this problem in a different way also. That's what I'm trying to show you. Just the way you can write is different. Understanding is exactly the same. Whatever I taught up till now point. Okay. Let's say this event, if it is drawn from bag 1, is referred as E1, and the event it is from bag 2, it is referred as E2. So this is E1, this is referred as E2. Okay. Now, what is the a priori probability? A priori probability, let's say it is capital Pi. Okay. So a priori probability means, as I said, what is the probability that E1 is happening? What is the probability that E2 is happening? The probability before the actual event, that the red ball is drawn. So before the actual event red ball is drawn, what are the events that happened? Bag 1 and bag 2. First you need to separate the sample space into few events, right? That's how it's going. First you need to demarcate the sample space. So what is that probability? E1 you can divide it in half, and E2 half. That's the probability, right? There are only two possible events, so half and half. And what is Pi? Given event E1 has occurred, given event E1 has occurred, that is bag 1. That I'm telling you right this time. Let's say bag 1 has occurred. What is the probability that it's a red ball? We know it's 3 by 7. Out of 7 balls, 3 are red balls. And given event E2 has occurred, what is the probability? It will be, if I say event E2 has occurred, that is, I am saying back 2, that we have got it from back 2. The red ball came from back 2. That's what exactly we are saying. So that is 5 by 11. Okay. So what is the probability that event E1 took place given red ball? So what is the probability that event E1 took place given it's a red ball? We have to multiply this by and this. So half times 3 by 7. That means we are first saying event E1 took place, and then we are saying what is the probability that it's a red ball given E1 divided by the entire sample space. Probability of this P of E1 given R plus P of E2 given R. I'm sorry. Probability of, so no, not this one. Exactly. So this is half times 3 by 7, right? So this what we are doing is the entire sample space, like half, like we are saying, okay, probability of E1 times, if it is like probability of red ball given E1, right? I just wrote the opposite here. So basically half times 3 by 7 plus probability that event E2 took place half times probability it's a red ball, given event E2 took place, so 5 by 11, right? So you see, it's same as this one, same thing as this one. That's why I said the concept is entirely the same. It's just a different way of representing, because we are just right. And I also prefer this way. In difficult problems, this helps. Like, first you write the a priori probabilities. What is a priori probabilities? First write the probabilities of the events. Here we directly did it. We directly wrote what is B2. What is the probability of that event E2 basically? E2 and B2 are same here. Okay, in this example I just wrote B2. In this example I wrote E2, but the same thing. So we directly wrote it as half. But let's say it's a difficult problem and you have a sorry, and you have some problem in finding what is this event E2, what is the probability. So in such scenarios, just one second. Yeah, in such scenarios, it helps if you write it down, if you break the problem into all the each events. Like, if you break the problem into events, what are the events that divide the sample space? What are their probabilities, a priori probabilities, before the actual event took place? What are their probabilities? And what is the probability of that event, whatever it is, A, B, C, that is given to you, given E1 has occurred basically, or EI has occurred here, let's say, because it's E1, E2, E3, E4. So now when you write all this, fill up all these terms, you fill up all these terms, and let's say now they want to know what is the probability that this event A happened due to E1, then you have to multiply this two divided by the total theorem of probability. This multiply this, plus multiply this, plus multiply this, and plus multiply this. Goes like this. Okay. So I hope this part is clear. I will be doing another part to probability three, probability. There I will cover like binomials, some binomial conditional probability, and rest some of the other stuff. Okay. So just to summarize what we learned here, we did conditional probability, independent events, right? We understood total theorem of probability and base theorem, right? And we solved a couple of examples to clearly understand these concepts. Okay. So I hope you guys enjoyed this video. Please like and share our channel if you enjoy it and if you find this useful. And also please don't forget to share it with your friends. Thank you so much. Bye. Have a great rest of the day.